So dito tayo ngayon sa transformer. So welcome to EE423. So nga pala, yung ating course title ay AC Apparatus and Devices. Pero dito, syempre magpo-focus tayo sa transformer. Okay, so maraming klase ng transformer. So ano ba yung transformer na tinutukoy natin? So hindi ito bali ito yung power transformer, yung karaniwan natin nakikita sa mga poste. So itong nasa right side, yung ating mga tinatawag na pole mounted transformer. Then itong nasa left side, yung mga pole mounted transformer natin, distribution transformer minsan tawag sa kanila. Then ito naman, ito yung floor mounted transformer natin, So ito yung mga transformer pang substation, pang main transformer ng mga power plants natin, generation power plants. Okay. So ano ba ang transformer? Okay, a transformer is a magnetically coupled circuit, that is a circuit in which the magnetic field produced by time varying current in one circuit induces voltage in another. Okay, it is a magnetically coupled circuit. So ano ibig sabihin nun? Later on, makalaman natin. Okay, it transfers energy from one circuit to another. Okay, but syempre, wala silang contact, So paano nangyayari yun? Okay, another definition, a transformer is static or stationary piece of apparatus by means of which electric power in one circuit is transformed into electric power of the same frequency. So take note tayo dyan, same frequency in another circuit. Okay, it can raise or lower the voltage in a circuit but with a corresponding decrease or increase in current. So pansinin natin yan, it can increase or lower the voltage with a corresponding decrease or increase in current. Okay, so when we say static, it's not moving, So bakit nasabing static to? So yung ating kasing transformer ay parang hawig sa electric motors, AC machines, ganun, So ang pinagkaiba, so it has the same principle, working principle, which is electromagnetic induction. So same lang sa ating AC machines like yung motors and generators, Kaya lang this one is stationary. So no rotating parts. Okay? So electric power, okay. One circuit is transformed into electric power of the same frequency, So when we say transformer, so that is apparatus that transfers energy from one circuit to another. Okay, of the same frequency, syempre. So from one circuit, yung frequency niya, same siya ng frequency sa secondary circuit, Okay. So ano yung gamit niya, So it can raise or lower the voltage. So depende sa paggamit. So halimbawa, bigyan ko lang kayo ng background. Kapag tayo ay nasa generation, so ang napoproduce natin diyan madalas ay 13 kV, 13,000 volts. So kapag ka dadali na siya, from our generation to our transmission, i-step up siya, So from 13 kV, dadaan sa transformer, magiging 69 kilovolts. Okay, or pwede na naman, so pag sinabing lower, halimbawa galing sa transmission, babagsak na sa distribution, so galing ng 69 kV, papasok sa distribution natin yan, transformer ulit. So magiging, babalik na siya sa 13 kV. Okay, so bakit natin ginagawa yon? So later on, makikita natin. So meron siyang corresponding decrease or increase of current. So makikita natin mamaya kung paano yung sinasabing decrease or increase sa current. Kung pag tinaas ba natin yung voltahe, tataas din yung current, or kapag binaba natin yung voltahe, bababa yung current, or otherwise, So for summary, it transfers electric power from one circuit to another It does so with a change of frequency. So, kung 60 Hz ka sa primary mo, o doon sa isang circuit, doon sa pagtatransferan mong circuit, ay same ng frequency, ano? 60 Hz din. It accomplishes this by electromagnetic induction. So, this is the working principle. So, malinaw sa atin yung electromagnetic induction, no? Where the two electric circuits are in mutual inductive influence of each other. So what does it mean when we say mutual inductive influence? So yung uh, uh, magnetic flux produced by two circuits, so nakaka-apekto sa bawat isa. So that and also meron tayong tinatawag na mutual flux, no? So that is the flux common to each circuit, ano? So how does it work? So paano nga ba gumagana yung transformer na yan? So ito yung basic illustration ng ating iron core transformer. So marami tayo kasing core na pwedeng gamitin. I think tatlo, no? Iron core, steel core, and air core. Meron ganun, no? So pero pinaka basic which is iron core. So paliwanag ko muna, no? Kung ano yung mga components natin. So three main components. So meron tayong primary winding. Okay, that is the circuit 1, diba? Meron tayong primary winding. Itong winding na to ay copper. Okay, tapos meron tayong secondary winding which is copper din, ano? Secondary winding. And meron tayong iron core. Okay, so kung napapansin natin, yung ating dalawang winding, primary and secondary, ay naka-wound dun sa ating core. Nakapalupot siya dun, ano? Bumubuo ng coil, di ba? Ngayon, don't get me wrong, ha? Pero yung dalawang winding na yan, sabi, without electrical, that is not electrically connected to each other, no? So, hindi sila magkadikit. So, merong insulation dyan, ano? Tamang nakapalupot siya dyan sa core natin, pero merong insulation, kaya not electrically connected, ano? Okay, so paano gumagana? So, from our electromagnetic induction principle, so alam natin, kapag ang current ay dumaan sa isang conductor, okay, ba, nagdaan yung current dyan, ay, so nakakabuo ka ng magnetic field or magnetic flux. Makapag-produce ka ng flux. Okay, so any current carrying conductor has a or induces flux, ano? Makakabuo ng flux. Then yung flux na yan, so ito yan, no? Magnetic field. So let's just say na ito yung nabuo niyang flux. So itong blue broken lines, ano? So yan, alam naman natin yung ma-generate or ma-induce niya na flux. Ganyan yung tsura niyan, ano? Sabog-sabog yan, ano? Diba? Kung naalala pa yung sa ating magnetic circuits. So ngayon, itong flux na nabuo na to, so magpo-propagate yan. Pag tama niyan sa kabilang circuit natin, sa secondary winding, so electromagnetic ulit. When there's a cutting of flux, a voltage is induced. Okay? So kapag tumama yan, nakat yung ating flux, nakat, sinong nag-cut? Siyempre yung conductor na tinamaan. Okay? Kapag tumama siya dito, propagation niya, tumama siya dyan sa conductor, so mag-generate ng voltage or mag-induce ng voltage yung ating secondary winding which is a coil, no? So, ganun nangyayari kung paano nalilipat yung energy from one circuit to another. Okay, so baka may magtanong, so di ba po kailangan ng continuous cutting of flux para makapag-generate or makapag-induce ng voltage? So, continuous yung movement ng ating magnetic field. Yan ay varying. Why? Because of the AC supply, no? Because of the frequency. So, alam natin, yung ating AC, so ito yung graph niya, di ba? From our AC circuits. Okay. So, the current is directly proportional with flux. Okay. So, kapag ka nag-maximum yung ating current, naka-maximum din yung ating flux. So kapag ka nag-zero, magsi-zero din. So yung nature ng ating supply ay alternating current, continuously changing. So nakakabuo tayo ng continuous cutting of flux because of that frequency. Okay. So tuloy tayo, ano? Ganun lang gumagana, ano? Then mag-induce ng voltage connected sa load. Okay. So let's go with the transformer construction. The simple elements of a transformer consist of two coils having mutual inductance and a laminated steel core. So, when we say laminated steel core, so yung ating core, yan, no? So, yan ay binubuo ng steel sheets, ano? Pinagpatong-patong. Imagine niyo yung parang gasket, ganun ang dating niya, no? Tapos pinagdikit-dikit lang. Okay, maraming ano yan, ano? Maraming steel sheets yan, tapos pinag-isa lang sila, ano? Hindi winelda, pinagdikit-dikit lang. The two coils are insulated from each other and the steel core. So, hindi electrically connected yan. Steel yan, ano? Tama, conductor. Pero, hindi sila electrically connected. So, ano yung nagpapagana? Yung mutual inductance, ano? O yung mutual flux. Kaya other necessary parts are some suitable container for assembled core and windings, a suitable medium for insulating the core and its windings from its container, suitable bushings, yung daanan ng conductor, it's either a porcelain or oil-filled or capacitor type for insulating and bringing out the terminals of windings from the tank. So yung karaniwan kasi nating nakikita ng transformer, yung distribution transformer natin, di ba? So halimbawa, ito yung loob ng transformer. So nandiyan yung ating core. May core dyan, ano? Sa loob yung core. Hindi naman sinasabing ganito exact na itsura. Tapos nandiyan yung winding. Illustration lang, ano? Merong winding dyan. Tapos itong winding nito, syempre, merong primary and secondary. Halimbawa, ito yung likod ng transformer. Okay, yung back, ano yun? Rear view, no? So ito yung may mga bushing dyan, ano, di ba? Dalawang ganun, ano? Isang live, tsaka isang neutral. Or pwede rin yung ground, di ba? Diyan papasok. Okay, yung dalawang conductor natin. Supply. Then ito, yung para secondary winding. So, meron madalas dito, no? Nandiyan yung terminal natin. Okay? Dito kakakonekta. Okay? So, ngayon, may laman na lang is yan, ano? For insulation. Tapos, for tawag din eh, for cooling din, ano? Cooling purpose. Okay? So, madalas yung ating insulation na ginagamit ay porcelain. Okay? Tapos, kailangan din ng case. Siyempre, yun yung magpo-protect sa iyong circuit. Hindi lang pwede nakalabas yung ano mo, no? Yung pinaka-windings mo. Okay? Ano pa ba? Okay. Let's go with, okay. In all types of transformers, the core is constructed of transformer sheet steel laminations, ano? Kagaya na nasabi ko, steel sheets, ano? Pinagdikit-dikit lang yung mga steel sheets para mabuo yung core. Assembled to provide a continuous magnetic path with a minimum of air gap included. So, ang purpose ng ating core is to concentrate the flux. Yung napoproduce na flux ng ating primary winding, kino-concentrate niya para siguradong or mas efficient, no? Yung tatama, no? Mas maraming flux yung tumama doon sa ating secondary winding para mas efficient yung pag-transfer natin ng energy. Meaning na efficient, less loss. Okay? So, with a minimum air gap. So, ano yung purpose ng air gap na yan? Ano? Minimum air gap. The steel used is of high silicon content. Sometimes heat treated to produce a high permeability. So when we say permeability, that is the ability of an object to produce magnetic field or flux, ano? And a low hysteresis loss. Okay? So yun yung mahalaga, ano? Yung low hysteresis loss. So losses yun, ano? Sa ating core. Okay? So pinapababa niya yung hysteresis loss. So it is a frequency dependent loss and a voltage dependent voltage dependent loss. The transformers are of two general types, distinguished from each other merely by the manner in which the primary and secondary coils are placed around the laminated core. So pwede tayong step up or step down transformer. The two types are known as core type and shell type. So yung sinabi kong pwede tayong step up or step down transformer, depende sa purpose o sa application. Pero ito sa core construction, ito yung two types niya, so core type and shell type. So merong mga bago, spiral core, wound core type, The trade name being Spiracore transformer, So madalang naman yan, pero meron. Okay. In the so-called core type transformers, the windings surround a considerable part of the core, whereas in shell type transformers, the core surrounds a considerable portion of the windings. So itong nasa kaliwa, yung ating core type. And sa kanan, shell type. Kung papansin natin, napapalibutan ng winding yung ating core. So meron dalawang leg, di ba? Based sa drawing, may dalawang leg siya. Tapos nandun yung ating winding, nakabalot doon. Meron naman, ito namang shell type, merong isang leg lang. Doon nakakapit yung winding natin. Sir, ba't isa na lang yung winding, di ba? Dalawa. Okay, ganito nangyayari dyan, Yung nasa inner part, so depende yan, So ito yung top view, halimbawa. Top view yan, So yung inner part ng ating coil, nung coil, diba ito yung pinaka, pinaka core mo, Tapos meron kang winding, So itong inner part, yan yung primary winding. Okay, so depende sa gamit, So tapos meron pang isang layer dyan. Insulated silang dalawa, Merong insulation na nilalagay sa pagitan ng primary and secondary. So ito yung primary, tapos itong nasa outer, yung secondary winding mo. Parang magka-sandwich silang ganun, So maganda rin kasi mas effective yung transfer ng or yung electromagnetic induction, mas effective kasi halos lahat nung na propagate or na-induce na flux or na-generate na flux ay nasasalo ng secondary winding. Unlike dito, so kung ba may yung flux mo, yan ang propagation, ganyan. Di ba? Ang tumatama lang na nakikita natin itong nasa side na to. Di ba? Yun yung lang tumatama sa secondary winding. So merong nasasayang. So yun yung tinatawag nating leakage flux. So those are the flux that doesn't cut by the secondary winding or ng ating coil. Okay, so yung flux naman na tumatama, yun yung tinatawag nating mutual flux. Yung flux na nasi-share nilang dalawa. Okay. Sana malinaw tayo sa part na yun, So what is transformer for? So ba't ba kailangan natin ng transformer? So transformers help improve safety and efficiency of power systems by raising and lowering voltage levels as and when needed, Improve safety. So bakit? Kasi meron tayong applications ng voltage na kailangan low voltage lang. So kung halimbawa sa bahay ka, papasukan mo ng 13 kV yan. So hindi pwede, And that is unsafe. Lalo kung napaka-accessible ng 13 kV. And also yung mga appliances natin, mga component natin sa bahay. So naka-design yan ng 230 volts. So we need the transformer. So alam natin yung O para pala sa kaalaman nyo, yung nakikita nyong linya ng kuryente, yung walang balot yung sa distribution mas mataas na tower, na poste, yun ay 13 kV, ano, line to line. Then, yung may mga balot, yun ay 30 volts, 230 volts, ano, papasok na sa bahay. So, yung palabas ng transformer. So, and efficiency, ano, ba't nasabing efficiency? So, kasi, ang nangyayari, upon the generation, di ba, nagtatransmit tayo, we need to, ano tawag din, deliver energy from one place to another. So, when we transfer energy, nag-step up tayo ng voltage. Ang nangyayari, kapag nag-step up tayo ng voltage, there is so-called that reduction of copper loss. No? So, paano nangyayari yon? Basta kailangan, alam natin, ang gamit ng transformer for efficiency, ano, to increase the efficiency of the system. So, paano mong tataasan yung efficiency mo? So, babawasan mo yung mga losses mo. Okay? So, depende yung paggamit yan, ano? May tamang paggamit ng transformer. Kailan ka magtataas, kailan ka magbababa ng voltahe. They are used in a wide range of residential and industrial applications, primarily and perhaps most importantly in the distribution and regulation of power across long distances. So, ito nga yung gamit niya, no? So, kapag ikaw ay nagdi-distribute ng power along long distances. So, kasi kapag masyadong nang mahaba, alam natin yung ating power that is equal to I squared R, no? Wherein R, that is the resistance of the conductor. Then, alam natin from our yung ating equation para sa resistance, that is rho L over A. The longer the conductor is, the higher the resistance. Habang mahaba yung conductor mo, tumataas yung resistance. Then, sa power, kapag tumaas ang ating resistance, tataas din yung power mo. Imagine that the power loss. So, kung mahaba yung conductor mo, tumataas yung power loss. So, ano dapat ang kailangan natin gawin? Kung ito ang equation niya, no? P is equal to I squared R. So, we can, reduce the current. So, paano nangyayari yun, ano? So, mamaya makikita natin. Paano nangyayaring bumababa yung current? So, hindi mo naman pwedeng sasabihin mo, tatabaan ko na lang po yung conductor para bumaba yung resistance. Hindi naman ganun basta-bastang pwedeng tabaan yung conductor. So, tandaan din natin na yung ating voltage drop, ano? So, VIR naman yan. So, makaka-apekto rin, ano? Okay. So, at first glance, iron core transformers appear quite difficult to analyze because they have several characteristics such as winding resistance, core loss, and a leakage flux that appear difficult to handle. Fortunately, these effects are small and often can be neglected, ano? So, kung i-analyze natin yung transformer, ano ba yung ina-analyze niyan? So, yung efficiency, pwedeng i-analyze, yung voltage regulation, yung pagpasok ng voltahe paglabas, ganong difference. Yung induced voltage sa ating coils, gano'ng diferensya, ano? Versus dun sa terminal voltage. Okay? So, magagawa natin yan by using the concept of ideal transformer. What does it mean when we say ideal transformer? So, we neglect the resistance of its coils. So, para sa losses ng coil, we neglect its core loss. Very basic. Ito yung basic na approach ng pag-analyze. Assume all flux is confined to its core and assume that negligible current is required to establish its core flux. Okay? So, ayun yung 4 conditions para makasabi mong ideal transformer siya, ano? Just for analysis lang naman, ano? Basic analysis. So, ito na. So, using Faradays Law, okay. So, ito yung mga ginamit natin. So, yung ating P sub M, that is the mutual flux. And E sub P, induced voltage in the primary. P sub S, the induced voltage in the secondary, and sub P, the number of turns in the primary side, number of turns, yung bilang nung pulupot ng wire, ano? The number of turns in secondary and sub S, ano? So, ano ba yung sinasabi nating induced voltage? So, halimbawa kasi ito yung supply voltage mo, E sub G. Okay? Pagpasok ng kuryente mo dyan, so nakakabuo ka ng flux. So, meron ka ngayon ditong induced voltage from the flux, ano? Then, makakapag-produce ka ng flux, tatama sa secondary. So, yung mabubong voltahe between this conductor, that is the induced voltage in the secondary winding. No? Induced voltage, tandaan. So, meron kang length of wire dyan. Okay? So, starting from here, let's assume this is terminal, no? Starting from here, that's a length of wire. So, meron kang voltage drop. So, this one, from here to here, that is the terminal voltage for the secondary. Okay? So, ganun din dito. Sabihin natin ito, V sub P for the terminal voltage for the primary side, no? And we have I sub P for the current in the primary side, and the current in the secondary side is IS. Okay, so tandaan natin, sa transformer, an ideal transformer has no loss. Okay, sabi na neglect daw yung core loss and yung kanyang copper loss, ano? So therefore, ang iyong power coming in is equal to the power coming out. So walang bawas. Kung ano ipapasok na power, yun yung lalabas. Anyway, yung sa transformer natin na apparent power yan, ano? Kung nagpasok ka dyan ng 5 kVA, ang output ng iyong transformer ay 5 kVA din. Tandaan, this is for an ideal transformer. Okay? So, dito naman tayo. So, E.M.F equation of a transformer. Okay? So, yung mga symbol natin ginamit. So, P sub M ngayon dito is maximum flux in Webers. Ano? Weber. Okay? This is yung ating V sub M can also be equal to V sub M times A. So, V sub M is the flux density, ano, or Weber per meter squared, times A, yung area natin, ano, cross-sectional area ng core. Then, F is frequency. And, ito same lang, ano, yung nabanggit ko kanina, yun pa rin. Okay. So, using still the, Faradays Law. So, we have the average rate of change of flux as V all over T. So, ito yung rate ng change ng flux natin, ano? So, let's have the graph of the flux. So, maximum flux kasi yung gagamitin natin dito, no? So, imagine natin to, ito yung graph ng ating magnetic flux. So, saan bang point nag-o-occur yung maximum, no? So, dito, kung papansinin natin, so, saan siya natapat? Sa 1/4 cycle ng ating isang buong cycle. 1/4 cycle siya, no? So, at 1/4 cycle, so we have T is equal to 1/4, ano? Okay, so F, yung ating T, that is the period. So, T is equal to 1 over F, di ba? So, to get this one cycle, for 1/4 cycle, we have T is equal to 1 over 4F. Okay, yun yung ating 1/4 cycle. So, at maximum flux, T is equal to 1/4 F. So, doon nag-o-occur yung maximum flux natin. Okay? The average rate of change of flux will be equal to Phi all over 1 over 4F. This is at maximum condition, ano, sa flux. Ipinalit lang natin tong T dito. Okay, so we have phi now all over 1 over 4f. So itinaas lang natin. So naging, kasi di ba ganito yan, phi all over 1 over 1 over 4f. So cross multiply lang. So we have now 4f phi sub m, ano? So maximum flux na kasi yan. So Weber per second or volts. This is the average rate of change of flux. Okay? Tandaan, average rate of change of flux. Then, average rate of E.M.F per turn is equal to 4F P sub M, ano? So dito, rate of change of flux siya, ano? So that is also equal to the average rate of E.M.F per turn. Kung naalala natin sa ating magnetic circuits, so N times dV over dt. So E, or the induced voltage, is equal to the number of turns times the rate of change of flux. Ngayon, kung ito pala ay rate of change of flux. So if we divide both sides by N, so that will be an average rate of E.M.F per turn. Okay, so this is per turn, ano? Tandaan, per turn yan, ano? Now, so kung tatandaan pa yung form factor ng ating sinusoidal wave, so we have the RMS value all over average value is 1.11. So we need the RMS value. So ang meron lang tayo, average rate of change, rate of E.M.F per turn. So ito yung average na i-induce na E.M.F kada turn, ano? So ibig sabihin, kung meron kang coil, so kada turn, ang nag-generate niya is 4F P sub M, ano? P sub M. Yan yung value na yan, ano? Per turn. So kung gusto mo kunin yung total, so i-multiply mo lang sa number of turns. Kaya meron kang per turn dyan, ano? If you multiply that into the number of turns, makukuha mo yung total average, ano? So ang kailangan kasi natin is RMS value or the effective value. Kung meron lang tayong average. So in order to get the RMS value, kung titignan natin to, we just need to cross multiply. Average value times 1.11. So we multiply this whole by 1.11. So meron tayo ngayong, so RMS value na, ano, of E.M.F per turn, that is equal to 1.11 times 4F phi sub M volts. So volts yung unit natin kasi E.M.F is also volts. Okay? Yun ang unit ng E.M.F, that is an electromotive force. Okay, so RMS value of E.M.F per turn is now 4.44F phi sub M volts. Okay, if we want to get the RMS value of E.M.F, so we need to multiply both equations by N. So multiply lang natin. So since this is per turn, we multiply it by turn also. So times N. So we obtain the RMS value of E.M.F, that is equal to 4.44F times N times P sub M volts. This is a units, ano? So the induced voltage equation now will be equal to E is equal to 4.44F times N times P sub M. So ito yung derivation, pinakita ko lang. So pwede rin natin siya i-represent. Kanina sabi natin P sub M is equal to B sub M, or the flux density, times area. So pwedeng ganun, no? So for primary circuit, so dalawa kasi yan, di ba? Dalawang circuit. So for primary, so ito papalitan mo lang. Teka lang, ha? Merong mali. Ba't nawala yung mga subscript? So this is subscript yung mga yan, ano? Delete ko lang. Live na live. Okay. So for the primary circuit, so pansinin ano, so induced voltage sa primary, ibig sabihin pag nagpasok ka ng voltahe sa primary mo, bawa ito yung primary winding. Secondary, pangit ang drawing. Pag nagpasok ka, magkakaroon ka ng induced voltage dyan. So nakadepende siya sa frequency na pinasok mong supply and yung number of turns ng primary side mo. Tapos syempre yung mutual flux, ano? Yung maximum mutual flux natin, which is V sub M. Given naman yan, madalas ano din, multiply mo ng 4.44. Or pwede rin yung nakapalit yung, or in terms of the flux density and the area, pwede rin naman, ano? And for secondary, pansinin, ano, E sub S now, or the induced voltage in the secondary side, napalitan lang yung number of turns ng primary to secondary. Kung ilan turns na to, yun yung makukuha mo, syempre. Okay, so hindi nagbabago yung mutual flux, yung pa rin. Okay, ang nagbago lang, number of turns. Okay, tuloy lang tayo. So now let's have the voltage ratio from Faradays Law again, ano? Doon pa rin naman. The induced voltage is equal to N times the rate of change of flux to, no? So this should be change of flux. So ito yung tinatawag natin change of flux, ano? Rate of change of flux. So di ba nagbabari yung ating supply dahil siya ay AC. So nagbabago-bago din yung flux mo. From 0 to maximum, maximum to 0, ganun siya, no? So for primary, ito siya. So E sub P is equal to NP, N sub P, times the rate of change of flux. Then for secondary, that is E sub S is equal to N sub S times rate of change of flux. So kung napapansin, ang pinagkaiba lang natin ay yung number of turns. So kung ginamit mong number of turns ay yung turns ng primary, so you obtain the induced voltage in primary side. Kung sa secondary naman, then sa secondary side yung makukuha mo. Okay? Now if we're going to divide the we're going to get the ratio, no, of EP and ES. So we have EP or E sub P all over E sub S is equal to N sub P times the rate of change of flux all over N sub S times the rate of change of flux. So papansinin, same lang itong dalawa. Magka-cancel lang yan. So we obtain this ratio or the voltage ratio E sub P all over E sub S is equal to N sub P all over N sub S. So ito yung very famous nating ratio, no? So ngayon, ito yung tinatawag nating voltage ratio or transformation ratio. Pangungunahan ko na. Okay, so sabi sa ating ideal transformer daw, the power coming in is equal to power coming out. Okay, P in is equal to P out. So we have the equation for P with the formula for P or the power, that is equal to voltage times the current. Diba? So kung yung power mo sa primary, yun yung pinapasukan, diba? Yung P in. So yung power doon, E sub P times I sub P is equal to yung output mo, syempre sa secondary side, E sub S times I sub S. So if you're going to divide both sides by E sub S and I sub P, both sides, E sub S, I sub P, so we obtain, so E sub P all over E sub S equal to I sub P. So meron tayong correction dito. So this should be I sub S. Okay. So we have E sub P all over E sub S is equal to I sub S all over I sub P. So ito pa isa nating ratio. So therefore we have E sub P all over E sub S is equal to N sub P all over N sub S is equal to I sub S all over I sub P. Paano nangyari yun, ano? So, kung naalala natin kanina, we have E sub P lang all over E sub S is equal to N sub P all over N sub S. So, since yung ating E sub P all over E sub S is equal to I sub S all over I sub P, so pwede natin i-equate to dito. Kasi we have E sub P all over E sub S yan, ano? Kaya natin nakuha ito. Okay. Bura-bura. Madali lang to, kaya mag-alala. So now, yung bawat parts ng ratio na yan, or yung bawat ratio na yan, so that represents the transformation ratio. So, we have A is equal to N sub P all over N sub S. So, pwede rin E sub P all over E sub S. Okay, this ratio is called the turns ratio, no? Or transformation ratio, tandaan, ano? And is given the symbol A. So, A yung gamit natin dito. Okay? So, pwede rin yung I sub S all over I sub P. Okay? So, yun yung mga pwede natin gamitin in the future. Okay. So, let's have an example. Paano ba natin ginagamit yan, ano? So, eto na. Madali lang yung pagsusolve dito sa transformer. Very basic. Okay, first example. A single-phase transformer sa 400 primary and 1,000 secondary turns. So, this is N sub P and this is N sub S. Di ba? The net cross-sectional area of the core is 60 cm squared. So, this is the area. Okay? If the primary winding be connected to a 50 Hz supply, so this is the frequency, at 520 volts, so this one, ano to? So ito ba ay V sub P or E sub P? Terminal voltage ba? So common sense, terminal voltage yan. Pero walang given na E sub P. Tama? So pwede natin isolve, ano? Kaya lang, paano natin isosolve? So wala kang So, ang isosolve natin, the peak value of flux density in the core. So, yung flux density, so yung B sub M ang hahanapin natin una. The voltage induced in the secondary winding, yun yung pangalawa. Ano daw yung induced voltage or yung E sub S? Okay. So, itry natin isolve. So, meron tayong equation, yung para sa ating induced voltage sa primary. So, ang hinahanap natin, malinaw. So, this is sub P, ano? Hindi yan times P. Ang hinahanap natin yung B sub M, yung flux density. So, all we need to do is we divide both sides by, okay, ititira lang natin yung B sub M. So, we divide both sides by 4.44 F N sub P. N sub P, ano, no? A. Okay. So, cancel dito yung 4.44 F. Yun. N sub P. And A. So, matitira na lang. So, we have B sub M is equal to E sub P all over 4.44 F N sub P A, ano? N sub P, ano? For the primary turns. So, ma-solve natin ngayon yung B sub M. So, substitution. So, yung ating E sub P, which is 520 volts, all over 4.44 times 50 Hz times 400. So, ito yung primary turns, ano? N sub P. Then, 60 cm squared, ano? So, yun yung area. So, para saan tong part na to? So, kasi yung ating given ay cm squared, ano? So, we need to convert that into meter squared. So, 1 meter squared is equal to 100 squared centimeter squared, ano? So, sana alam yung conversion na yun, ano? So, cancel cm, matitira 1 meter squared. So, calculator tayo. So, we have 520 all over 4.44 times 50 Hertz times 400 times 60 times yung ating conversion factor na 1 over 100 squared. So we obtain 0.976 o 0.975 na, no? Round off natin 3 decimal places. So we have 0.976 Weber per meter squared. So ito yung ating flux density. So yung ating number 2, so the voltage induced in the secondary winding. So we use, pwede na itong ratio na to, no? Since ideal transformer naman yung ano pa natin, ano? So we have E sub P all over E sub S is equal to N sub P all over N sub S. So meron tayo nitong dalawa. Pansinin, kapag gumagamit ka ng ganitong ratio, apat yung values mo. So para makasolve ka, you need at least 3, no? So 3 values para makasolve ka. So ang nawala na lang natin ay secondary. So reciprocate lang natin both sides, ano? So we have now E sub S. So pag binaliktad natin, E sub S all over E sub P and N sub S all over N sub P. Then cross multiply. 'Di ba? Binaliktad lang natin yung S, yung mga secondary component na punta sa taas. Then dito merong E sub P, kinross multiply lang natin, 'di ba? So ito yung kinalabasan. Then we substitute. So we have now, so E sub P natin is 520 pa rin. So we have 520 volts times 1,000 all over 400. Yung 1,000 natin, yun yung secondary turns. Then yung 400, yung primary turns. Okay? So, solve natin, ano, para makita. We have 520 times 1,000 all over 400. So, we have 1,300, ano. So, 1,300 volts. Okay. Another problem. A 25 kVA transformer has a 500 turns on the primary and 50 turns on the secondary winding. The primary is connected to 3,000 volts, 50 Hz supply. Find the full load primary and secondary currents, the secondary E.M.F, and the maximum flux in the core. Neglect leakage drops and no load primary current. Okay, so una nating hanapin, find the full load primary and secondary currents. So paano natin kukunin yung current sa primary side? Napakadali, i-divide lang natin yung ating power or yung apparent power natin with the primary voltage. So 3,000. So we have S is equal, or the apparent power is equal to I sub P times V sub P. We divide lang, no? We solve for I. So we have I sub P is equal to S all over V sub P. Substitution, we have 25,000 volt ampere all over 3,000. So solving, so we have 25,000 all over 3,000. That is equal to 8.33 amperes. Okay, so yun yung ating I sub P. So we need to get the secondary current. So we can use na this ratio. So alin dyan ang gusto mong gamitin? Yung isa, ito bang induced voltage, saka yung ISIP, o yung current? So hindi mo pang pwedeng gamitin kasi wala ka pa ng secondary induced voltage. So mas magandang gamitin, kumpleto ka ng turns. So mayroon kang 500 saka 50, yun na lang gamitin mo. Since you are solving here for you are solving for the secondary current, na nakasa na agad, ano? So you can cross multiply lang, ano? I sub P. So you have I sub S is equal to I sub P, N sub P all over N sub S. Ganun lang kadali. Then we substitute. So yung ating I sub P, nakuha natin 8.33. Then yung primary turns 500 and secondary turns 50. So you have, okay, pakita natin sa calculator. So we have 8.33 times 500 all over 50. So you have 83.3. So yun, 83.33 amperes. Okay. So ano pa nawawala? Secondary current, meron na. Secondary E.M.F. So now you can use this one, ano, to solve for secondary E.M.F. So we have now, so nireciprocate lang natin ulit, binaliktad lang. Then cross multiply yung E sub P. So you have now E sub P is equal, E sub S is equal to E sub P times N sub S all over N sub P. So E sub P natin nakuha meron, or 3,000 volts. So ayun, times yung ating secondary turns, which is 50, all over 500, the primary turns natin. So we have, para ka lang nag-divide 10 dyan, 3,000 times 50 all over 500. So that is 300 volts. Okay. So ano pang nawala? P sub S, 300 volts. Then, yung ating maximum flux in the core. So, P sub M yung nawawala, no? Isa pa hinahanap. Okay. So, using our equation for induced voltage for primary side, pwede rin naman secondary na sa iyan, ano? Pakita natin, ano, na magkamukha yung makukuha. So, yung ating frequency ginamit, okay, ayun, 50 Hz. Then, yung primary turns, 500, okay? Ang hinahanap nga lang natin yung ating phi sub m o yung maximum flux. So we divide both sides and to make phi sub m alone, ano? So pag-iisahin natin yan, ano? So we have now phi sub m is equal to E sub p all over 4.44 f n sub p yan, primary terms, ano? Okay, so substitution, we have yung E sub p natin, 3,000 volts. Then we have 4.44 constant times 50 yung ating secondary frequency, 50 Hz. Then yung ating primary turns, 500. Okay, solving now. So we have 3,000 volts all over 4.44 times 50 times 500. So we have 0.027 Weber or 27 milliweber. Ano? Nag-asuglan tayo. 1, 2, 3. So, milli. So, we have 27 milliweber. Okay? Sir, pwede bang secondary gamitin? Secondary components? Pwede, pwede. So, meron kang E sub S, meron ka ring N sub S. So, remember yung ating equation, we have E sub S is equal to 4.44 F times N sub S P sub M. So, tingnan natin kung pwede, no? Didivide lang natin yung both sides ng n sub e, itong part na to. Didivide natin both sides. Parang ganito lang din. So, mangyayari lang dito, ito magiging n e sub s, kasi ito magiging n sub s, ano? Testing natin kung parehas sila na makukuha. Nasa inyo yung kung ano yung gagamitin nyo, no? Okay. So, we have e sub s that is equal to, ayun, nasolve natin, 300 volts. Then, 4.44 times yung ating frequency, 50 Hz pa rin, ano? Same lang. Without change of frequency, di ba? Natandaan. Then, n sub s is 50 turns. So, solving, we have, so, yun pa rin. Same lang na sagot. 0.027 Weber. So, pwede natin gamitin, ano? Secondary or primary turn components, ano? So, ano dapat nating mapansin sa problem na to? Kung napapansin, doon sa primary side, yung voltahe natin 3,000. Pero yung ating current ay 8.33 lang. Tama? So, dun sa secondary side natin, 300 volts lang. And yung ating current, 83.33. Ano? Times 10 nung primary. So, napansin, ano? Mataas voltahe, mababa kuryente. Mababa voltahe, mataas kuryente. So, siguro na medyo nabubuo na sa isip kung bakit ganun ang kailangan nating mag-step up o step down. Ito isang kahalagahan. Okay. Balikan lang natin ng konti, ano? Screen. Then, tapos yung kulay in color dilaw. Okay, so naalala, no, yung ating ratio, E sub P all over E sub S, these are the induced voltage, is equal to I sub S all over I sub P. Okay? Kung napapansin, yung primary natin, nasa taas yung voltage, nasa baba yung current. No? So, ibig sabihin nito, the voltage is inversely proportional, no, with the current. Kapag tumaas yung voltahe mo sa primary, babagsak yung, sorry, baliktad yung ginawa ko. Kapag ka tumaas, okay, pen. Kapag ka tumaas yung ayong primary current, bababa yung iyong voltahe. Okay? Tama ba? Mali. Nalilito na ako, inaantok na ako. Okay. So let's put this in this way, no? So E sub P is equal now to E sub S all over I sub S times I sub S all over I sub P. So kapag ka tumaas ang iyong I sub P, bababa ang iyong E sub P. So same thing other way around, no? So kung meron ka namang I sub P, so cross multiply natin E sub S, I sub S all over E sub P. Kapag tumaas yung iyong voltahe, babagsak ang iyong current. So yun yung mas tama, no? Kapag ka tumaas yung voltahe, babagsak yung current mo. So kanina, sabi natin, di ba, yan yung ating transmission line. Halimbawa, generation to. So meron kang transformer dito. Okay? So ito distribution side na to. Consumer. So pagpasok ng iyong voltahe dyan, 13 kV ka lang, ano? Okay? So pagpalabas dito, 69 kV na. So dito, halimbawa, meron kang 5 kVA. Bawa lang, 5 kVA ang iyong current. Ano mas maganda? 5 kVA ang iyong power na itatransmit. So sa 13 kV, alam natin mas malaki yung current mo dyan, ano? Yung current mo dito mas mataas kasi mababa ang iyong voltahe. Ngayon, pagpasok ng 69 kV niyan, tumaas na yung voltahe mo. Tumaas siya, di ba? So, bababa yung current mo. Okay? So, alam natin na yung power loss, that is equal to I squared R, no? Ito, constant yung R mo, no? Dahil yung length ng conductor, kasi yung taba niya, constant. Ngayon, magbabari yung iyong current. Kapag ka bumaba yung current mo, bababa rin yung power loss. Okay? So, ito yung pinakamahalagang effect nung pag-step up or step down ng voltage to reduce the power loss. So, alam natin yung power loss. So, binabawas yan sa ating power. So, power output is equal to power in minus the copper loss, ano? Or any other losses. So, kapag tumataas ang iyong copper loss, bababa ang iyong output. So, alam natin na efficiency, that is the power output over power input. Okay? So, habang bumababa ang iyong output, bumababa rin ang efficiency mo. Okay, yung usable energy or power, nababawasan. So, that is the reason why one of the reasons why we step up or step down voltage. Okay, so for efficiency ng ating power system. Okay, so any conductor na daanan ng kuryente ay nagdi-dissipate ng energy. So yun nga yung power loss. So ang aim natin, mabawasan yung power loss. I-step up natin yung voltage, bababa yung kuryente, bababa yung power loss. Okay, so sana malinaw sa atin yung part na yan. And yun lang. Okay.